I think it's quite tempting in this question to jump straight in and just see, oh, I see the word density, therefore I'm just going to do my density equals mass over volume calculation. It's great that you've got that information, but what you do need to make sure is that you've read the question carefully because there are some subtle things that are going on here. Okay, so first of all, he collects a sample of 1,000 ball bearings. We know the radius of each one, and you'll see that that's measured in centimetres. The total mass of the ball bearings is this, which is measured in kilograms. So remember, there were originally 1,000 of those ball bearings, and it's 1,000 of them that weigh this much. So one is obviously going to weigh much less. The question itself asks us to calculate the density, so we know we can do that with our formula, but it tells us that it wants us to do the answer in kilograms per metre cubed. So the two units which make up that together have got to be the units you put into your calculation. So the mass that you put in must be in kilograms, the volume you must put in must be in metres cubed. Which means that as this is in centimetres, we'd be better off putting that into metres first before we do any other calculations. So my first calculation that I might be thinking about is to get the volume of just one ball bearing. Okay, so step one, I'm going to do the volume of one ball bearing. Okay, now there's a possibility that you might not know what a ball bearing is. However, this word ball, we know what shape a ball is, it's a sphere, so we're going to be using the formula for the volume of a sphere. As I said though, the radius is 0.8 centimetres and we want that in metres. So we've just got to divide by 100, which will give us 0.008, and now we've got our result in metres. Now for our formula, 4/3 pi r cubed, and that's given on the front of your paper in case you couldn't remember it. So it's going to be 4/3 times pi times 0.008 cubed. And that comes out at 2.14466 times 10 to the minus 6. Again, I've left it to many decimal places because that's not my final answer. And we put in metres into that formula, so our answer is going to be in metres cubed. Okay, now I know the volume of just one ball bearing. I need to work out the mass of one ball bearing. So part 2, mass of one, we might start abbreviating here, ball bearing. So that's going to be 16.935 divided by 1,000 for just one of them, as that's the mass of 1,000. So that's going to end up being 0.016935 kilograms. Only now that I've got my volume in metres cubed and my mass in kilograms, am I able to actually do the density calculation. So for my final step, step 3, I can now do my density, which I know the formula for that, it's mass over volume. And even if you couldn't quite remember it, you can actually see it from the units. Because if the units of density are kilogram per metres cubed, you must be doing something in kilograms divided by something in metres cubed. So the mass is 0.016935, and we're dividing by 2.14466 times 10 to the minus 6. Give me a final answer of 7,896 kilograms per metre cubic. And that's about right for what you'd expect of a metal. There we go.